Welcome back to the GoEngineer YouTube channel. In today's video, we'll take a look at Cloud Compute Changes Everything, how we do fast and affordable Abaqus FEA. Please make sure to hit that subscribe button if you haven't already. Let's dive in. But before we begin, I would like to introduce myself. I am Marcel Ingels. I'm one of the senior simulation specialists at GoEngineer. I'm out of Ann Arbor, Michigan. My day-to-day is typically using Abaqus for structural simulation, and I spend a lot of time looking at medical devices, composites, and nonlinear mechanics. About me in particular, I really enjoy golf, football, and I have a dog. And a fun fact, I am a triplet. With that being said, I'd like to talk a little bit about GoEngineer. GoEngineer is nationwide. Last year, we did have the acquisition of computer-aided technology. We are very excited to offer the full product line of Dassault systems in the CATIA, Innovia, Delmia, and Simulia brands. The Simulia brand being the brand we'll be talking about today, specifically related to Abaqus. We do have 60 plus offices across the United States, as well as 220 technical resources certified for SOLIDWORKS and Stratasys. And we also have a bunch of certified Abaqus engineers as well, myself being one of them. So to just talk about our simulation consulting team, we have 22 US simulation engineers. We have a variety of backgrounds represented from automotive, aerospace, consumer, defense, energy, and medical. We offer a full suite of different types of simulation consulting services, ranging from full product development to optimization, multi-physics, as well as some of the complex physics related to CFD, noise, vibration, harshness, and impact and crashworthiness. Where this story is kind of going to go is we going through some acquisitions. We were looking to really grow our team, and a couple years ago we were really presented with a question of, how do we want to invest to grow our team as effective as possible. And we kind of had to take a look at what our hardware situation looked like. So, our main machine was an 80 CPU cluster, as well as 3 16-core towers, all ranging between 6 and 10 years old. And I even point out some portable air conditioners that we had to have to keep everything properly cooled. And this was a significant amount of money invested that we did use for quite a while. But the questions that we were starting to ask ourselves was, when we were looking to replace, there were a lot of supply chain issues, as well as, are we getting the most return on our investment for the hardware that we have, and trying to manage some of the more day-to-day stuff like bottlenecks when we have a lot of throughput. I don't know if anyone has submitted jobs in the command line and seen the picture in the bottom right when when your job's due. It seems like everybody else has stuff that's in line as well. With us being dealing with some complex hardware, we spend a lot of time maintaining that. And that's time where our engineers or IT staff could be doing other projects or value added tasks to other aspects of the business. We're dealing with like our old cluster. Things like the operating system wasn't supporting the latest version of Abaqus, and just dealing with kind of silly things like the room not heating or cooling properly, and getting some overheating warnings, turning computers off, as well as having to run to Costco to get a UPS replaced that failed, as well as drives going bad. So there's a lot of things that we were dealing with that we really just didn't necessarily think that buying a very expensive new computer was the perfect solution for us. And then, the next thing, just kind of summarizing that, we kind of have we started out doing workstation computing, and this is actually my manager who very kindly allowed me to, or gave me a picture for this presentation of his first use of Abaqus in the 90s. And then we, moved towards this kind of distributed computing model. And then, we were very interested in understanding, what is available on the cloud. So, we're very interested in having our data on the cloud, having our license served on the cloud, as well as the execution of the solver. So, that brings us to this next base, where this next idea of DSO rolling out a couple different licensing schemes, related to credit-based licensing. So the tokens are what most people that use Abaqus are familiar with, and you basically buy tokens either perpetually, yearly, or quarterly, and you will basically check those tokens out, and they'll solve your job, and then they get checked back into the license pool, and they can then be used later. The tokens do follow a non-linear curve, so 16 tokens is about 16 cores, and then like 35 tokens is 110 cores roughly. So you kind of have that non-linear token to core ratio. So that's kind of the type of licensing that's been around for a while. Then about 3 years ago, Dassault released what was coined as the credit-based licenses. So what these do is you buy these in packs of 1,000, and I think Dassault did a really good job of making these roughly about $1 a credit. So you can kind of look at credits per hour the same as dollars per hour. And these credits deplete when you solve them, and you will reload as needed. So we're really interested in kind of understanding what this credit-based licensing scheme could look like, as well as the cloud hardware. So we decided to go forward with that. Now, this was actually this period where we moved over to the cloud. This actually happened a couple of years ago, and we monitored our compute needs, and what you kind of can see is our usage really was like this peak and valley type of scenario, where there's a lot of periods of time over the course of a week where our tokens weren't being utilized. We're paying for them, but they're just sitting idle on the shelf. So when we noticed that a lot of our demand really kind of stacked on top of each other on specific projects were coming through that needed to be done in a very timely fashion. So right off the bat, we kind of felt like we were onto something, but then we started to see a few other things as well. So, we do a lot of full vehicle crash analysis, and you typically have to do like 4 different crash scenarios when you're running this type of analysis. So if a customer wanted one change, and they wanted to run all 4 crash scenarios on our cluster with 80 cores, that would take us 20 hours times 4, so 80 hours to get all 3 of those done, a good chunk of your week. Whereas on the cloud for 144 cores, those same 4 runs could all be done in parallel in 12 hours. So we're really getting some eyebrow raising performance, seeing like, okay, well, we can start getting stuff done a lot faster. But then we started thinking about, well, how does that relate to cost? And we started to find out that we were actually incentivized to run faster with this credit-based licensing scheme. So we would, typically, we ran this job on 3 different core configurations, and it actually ends up being cheaper to run it on the core configuration it's most optimal for. So every job is going to have an inflection point on how well it's split up to be parallel processed. So for this particular model, it actually you can't really not run it on the highest number of cores. Like in this case, 144 cores was the configuration, the highest core configuration available when I did this study. So it's really exciting because it's, this idea of like enabling high performance computing, for any installation size. You have access to that 144, 192 core configuration. This is what it kind of felt like, when we had the token-based licensing. It felt like a fixed flow rate type of situation to put out a fire, when what we really needed was a variable flow rate, and able to kind of go to that very high throughput, with the credits. And our customers were benefiting from that. So this graph is, I really enjoy this graph. We looked at all the number of jobs that we did, or the number of analyses that we did over the course of a few years. And as we were able to return results to our customers, they started to ask for more iterations. They started to rely on iteration. They started to rely on analysis more, and we were able to provide a much larger amount of value to our customers. Just because we remove those breaks by going to a flexible licensing scheme. So it's really been a tremendous game changer for us, and while remaining flexible the whole time. So this is kind of 3 just example problems. Like the cloud, or just the flexible licensing in general, whether it's on cloud or not on cloud. There's very attractive options for both small and large jobs. So you could do a modal analysis on a pretty complex battery pack, and it's only going to cost you $1. Or you can go all the way to a very large crash analysis, where if you needed a sizable installation, or a sizable licensing configuration to really get this through in a meaningful period of time, you're looking in the tens of thousands of dollars, or even more, to get something licensed effectively to get a job you might not need to get done that many times over the course of a year solved. So it really is I think can be a benefit at any type of analysis, depending on how many and how frequently you need to solve them. One of the other things that we really became to appreciate as well is that everything is tracked. So how many credits are consumed by each user, as well as by project. So you have a very granular level of data that you can use to apply to understanding which jobs are costing more from a simulation perspective. Where if you go to a more traditional token-based license, it's kind of difficult to amortize those costs over the whole year, because it's difficult to know when you're making the purchase how much they're going to be used. We also found how flexible this system was, from the perspective that you could use the platform GUI, which is the 3D experience products, or you could use the traditional Abaqus or even third-party tools, as it just requires the input file. And we'll look at a little demonstration of how that's used in a couple slides. And what's nice is you're able to do a hybrid approach. You can use both tokens and credits, so you don't have to necessarily commit to either or. And so that's what we've done is we greatly reduced our token installation. So we just have one of these 16 core machines licensed, and we might do some simple stuff on those standalone computers, anything that might be ITAR related, and then we will use the cloud for basically everything else. Anything from small static to multi-million element node count explicit crash models. There's a variety of other ways you can do this though as well. You can this is set up to, you could use your own cloud if you have your own cloud environment. You could install Abaqus, the Abaqus solver, and license it with sim units. That would give you a lot of flexibility. I do think that the DSO did a really good job setting up their cloud system GUI. A lot of nice user experiences have been developed, but if a customer already has their own cloud resources that they've invested in, this is a great option for that. And then there's also kind of the sporadic minimal use setup. So, if you just entering into Abaqus and you kind of want the most base level installation, you can just get a seat of Abaqus and 1K credits, and you can just reload those credits every time you run out. 1K is a little, you might want to go a little bit higher than 1K just so you can get a feel for what your use cases are, so you don't have to reload a bunch of times before you get an idea of what your burn rate will be. But this is a very attractive, just the minimal amount to get started to get a feel for how Abaqus works without having to commit to a very large token installation. So before we get into the demonstration, just to summarize, so we felt that this tool was a fantastic solution to manage our peak simulation demands with parallel runs. The 192 cores enabled us to high performance computing without having to commit to a fully licensed 192 core token configuration, when we really only need that for a small percentage of the year. We've eliminated our maintenance and hardware costs while still maintaining the preprocessors that we like to use. We've been able to really get a great understanding of what our costs are to make sure that we're tracking everything appropriately, and then we maintained our flexibility by having a mix and match of licenses. So with that being said, feel free to put any questions into the chat. I'll answer them after the demo that I'm about to go through. But that's about it for kind of what I wanted to talk about. I think now I just want to show everybody how smooth or how easy to use this GUI is. So as you can see, I'm creating a simulation object, just giving it a title as well as a description. And this is kind of like the project name, the vehicle analyses, and then this analysis case is the actual analysis or iteration. So as you can see, it then populates on the left-hand side, and I'll just drag my IMP files into there, and you can see they upload into the cloud server. And then let's say I want to make another analysis inside of this project. So this one will be like a knee bolster impact. So then I'll drag these files into that. And one thing that's really nice about this is I can actually open up these IMP files while I'm in here. So I can double check my loads. I can double check my output requests, make sure it all looks good. It is limited to 10 megabytes, but you can split that up with include files. And do that for the second case. Check your material properties. And then when you go to launch this off, you go through the setup and you can pick, they keep like the last 4 releases of Abaqus available. You can do an analysis or a data check and then pick your precision. And then you can do what's called a generate 3D experience content. This is gonna be our lightweight post processor, which is really nice tool. We'll show in a minute. So we'll just launch these off simultaneously. I can do restart analyses if I'd like. Like I can solve them sequentially to do all the different restart related activities. So you see, I'll switch these over to credits and I'll run them in parallel. And now I'll change the core configuration for each of these. So I'll just pick 18 cores for each job. And then they're both going to run. I'm going to launch them off simultaneously. So this is running in real time. And you can see now up at the top, the first one has the little blue bar, so that is now currently running. And then the second one just got queued up, and that'll start running in just a second. And now that one's running as well. So we'll go to the next slide now. And now these have finished running. They only took a few minutes each. But the normal files that you would download to bring into Abaqus CAE to view are available, as well as any of the other diagnostic files. While the job is running, you do have the ability to monitor different outputs such as energy, kinetic energy, stable time increment, all the different things that you would want to view in regards to convergence criteria, as well as you can look at the status log, data, message file, all in real time. So nice to be able to have those functionalities to see while the system is running. I can then look at a summary page, and I can look at how many credits each job consumed. As you can see here, they both ran in about 2 or 3 minutes, consumed three credits. So now I'm going to do a little bit of post processing on lines. This is pretty neat because this is all happening on the internet. So this is a knee bolster impact. And you get a little summary of the model, the different element types, the nodes, element numbers. I can progress through the different frames, and I can switch it to different types of outputs. I can animate it. I can change the speed, just everything you would need in kind of a lightweight viewer. So this is really nice. You can run your jobs, and then someone on an iPad or anything with internet, they can log into this system, and they can see this different types of results without having to download anything. So I'll switch over to the other side impact model. Again, gives you that summary when you switch over. And I look at the stress results. You have the full 3D manipulation available, similar to how you would with like a locally installed tool. So I'll animate this one. It's pretty cool, explicit airbag analysis. So you can do simple stuff like measure. You can apply sections. You can annotate. You can export animations, and everything you would need from kind of a simple post-processing perspective. So yeah, and then the one thing that's also nice is you see when I hover my mouse, you can see the different field output for each node. So it's a nice way to confirm, like, did this go to this distance, or what the peak value is. You can also add max and min labels. So that does complete what I have from a demo perspective, as well as the webinar as well. Thank you for watching. If you enjoyed this video, please subscribe and leave us a comment below if you have a topic you'd like us to cover in a future video. Visit our website, goengineer.com, for access to professional training, upcoming events, and more from your #1 online technical resource. Bye for now. Thanks.